In 1936, a German archaeologist opened a clay jar near Baghdad and found something impossible. Inside a 2,000-year-old Parthian tomb sat a simple terracotta jar, 14 centimeters tall, a copper cylinder sealed inside with asphalt, an iron rod down the center. It looked like a battery. And when scientists tested a replica, it worked like one. Fill the jar with vinegar or grape juice. Connect the metals, voltage appears. 1.1 volts, enough to feel a tingle on your tongue, enough to electroplate a thin layer of metal. The question that has divided scientists for nearly 90 years is simple. Did the Parthians invent the electric battery 2,000 years before Volta? The artifacts were found at Kujut Rabu, a village southeast of Baghdad. The site dates to the Parthian period, roughly 200 BCE to 200 CE. The Parthian Empire controlled Mesopotamia, Persia, and parts of Central Asia for nearly 5 centuries. They sat at the crossroads of the Silk Road. Roman, Indian, and Chinese goods all passed through their territory. Wilhelm Koenig was the German director of the Iraq Museum when the artifacts arrived. He was the first person to suggest they might be galvanic cells. His argument was straightforward. The components matched the design of a simple electrochemical cell. Iron and copper in an acidic solution create a voltage difference through galvanic corrosion. The electrochemistry is real. There is no dispute about that. Any acidic fruit juice between 2 different metals will produce current. The question is not whether it produces voltage. It can. The question is whether it was designed to. The battery hypothesis has been tested repeatedly since aDNA first proposed it. In 1940, Willard Gray at General Electric built a replica using copper sulfate as the electrolyte. It produced 2 volts, enough to electroplate a thin gold layer onto a small silver object. In 2005, the television program Mythbusters built 10 replicas connected in series. They successfully electroplated a coin with a thin layer of metal. Every replica test confirms the same result. The design works. And there is physical evidence that supports the electroplating theory. Some Parthian artifacts show gold layers so thin, and even that fire gilding cannot explain them. Fire gilding uses mercury to bond gold to silver. It leaves traces of mercury in the surface layer. Some Parthian pieces show no mercury at all, only gold directly bonded to the substrate. The Parthians were not primitive. They built cities, minted coins, and traded with Rome. Their metalworking was sophisticated. Gold and silver alloys, mercury gilding, and fine filigree. The gold plating on their artifacts became thinner and more uniform over time. Hammered gold leaf averages 10 to 50 microns. The thinnest Parthian layers measure under 2. 2 microns is thinner than a human hair. Hammering alone cannot produce that. This physical evidence keeps the debate alive. The question is whether electrochemistry is the only explanation for layers this thin. If they did not use mercury and the layer is too thin for hammering, how was it made? Different electrolytes produce different voltages. Vinegar yields about half a volt. Citric acid yields more. The Parthians had access to all of these. Wine vinegar was a staple of the ancient world. They did not need to understand electrons. They only needed to observe the effect. Place 2 metals in acid. Notice the tingle. Notice the thin gold film forming over hours. Empirical discovery does not require theory. It requires observation and repetition. A Parthian goldsmith who noticed this effect could have refined it over a career without ever writing it down. Craft knowledge in the ancient world was passed orally, from master to apprentice. When the last craftsman died, the technique died with them. It has happened 1,000 times. That is the strongest argument for the battery hypothesis. But it is not the only interpretation. Most mainstream archaeologists reject the battery interpretation entirely, and their arguments are serious. They deserve to be heard. The first objection is context. No wires have ever been found at the site. If these were batteries, something had to connect them. but no copper wire, no conductive thread, no leads of any kind were recovered. The second objection is function. 1.1 volts is not useful for anything visible. You cannot light a lamp. You cannot power a device. You cannot create a visible spark. Electroplating requires hours of sustained current and multiple cells connected together. The third objection is the most damaging. The artifacts look exactly like known scroll jars. Similar jars from the same period have been found with papyrus scroll fragments inside. The copper lining would have protected scrolls from moisture and insects. The scroll jar interpretation gained support in the 1980s and 90s. Similar jars from Seleucia, another Parthian city, contained papyrus fragments. If identical jars from the same culture held scrolls, why would this one be different? The copper lining makes sense for preservation. Copper has natural antimicrobial properties. The asphalt seal keeps moisture out. The iron rod supports a rolled scroll. Every component has a simpler explanation. And in archaeology, simpler usually wins. The copper lining would have protected scrolls from moisture and insects. The iron rod could have been a support pin for the scroll core. Every component has a simpler explanation. And in archaeology, simpler usually wins. But the debate did not end there. In 2004, a team at the University of Mainz conducted the most rigorous test yet. They built exact replicas using materials available in the Parthian period. Grape juice as the electrolyte, gold chloride solution as the plating bath. After 8 hours, a thin but visible gold layer had deposited on the test object. It was fragile, but it was electroplated gold. The SEM analysis confirmed the gold layer was between 1 and 5 microns thick, consistent with the thickness observed on some Parthian artifacts. But the skeptics pointed out a critical weakness. The experiment proved the concept works. It did not prove the Parthians used it. Proving something is possible is not the same as proving it happened. There is one more layer to this story that most accounts leave out. The original Baghdad battery artifacts were looted during the 2003 invasion of Iraq. Many have since been recovered, but the condition of the originals is uncertain. Modern techniques that did not exist in Koenig's time cannot be applied to artifacts we cannot locate. Neutron activation analysis could determine whether the copper cylinder was ever exposed to an electrolyte. Residue analysis of the interior could identify whether grape juice, vinegar, or any acid was present. X-ray diffraction of the iron rod could reveal electrochemical corrosion patterns distinct from simple rust. Every one of these tests is non-destructive. Every one would help settle the debate. But you cannot postpone what you cannot test, what you cannot access. The broader question is what the Baghdad battery represents regardless of its original function. Mesopotamia was the birthplace of writing, astronomy, mathematics, and law. The idea that they might also have discovered electrochemistry is not impossible. Ancient civilizations routinely discovered principles that were later rediscovered independently. The Antikythera mechanism proved the Greeks built analog computers 2,000 years ago. Roman concrete proved they formulated self-healing building material that modern engineers are still studying. The pattern is clear. Ancient innovation was real, widespread, and frequently lost. Hero of Alexandria built a working steam engine in the 1st century CE. It was used as a novelty. The Industrial Revolution would not happen for another 17 centuries. Technology is not always adopted. Sometimes it is discovered and forgotten. Damascus steel was forged for centuries. The technique was lost completely by the 18th century. Modern analysis revealed carbon nanotubes in the blade structure, a material we thought we invented in the 1990s. The ancients did not understand the physics behind their innovations, but the innovations were real. Zhang Hong built a seismoscope in China in 132 CE. It detected earthquakes hundreds of kilometers away. Court officials called his predictions false, until a messenger arrived confirming the distant quake. These discoveries proved that ancient minds were capable of extraordinary technical insight. The question is always the same. Did they know what they had, or did they stumble onto principles they could not explain and eventually forget? The Baghdad battery sits precisely on that boundary between discovery and accident. The debate over the Baghdad battery reveals something about modern assumptions. For centuries, Western scholars underestimated the technical capabilities of non-European civilizations. The idea that ancient Iraqis discovered electrochemistry still makes some scholars uncomfortable. But discomfort is not evidence, and neither is enthusiasm. The scientific method does not care what we want the answer to be. It only cares what the evidence shows. And the evidence is locked inside a museum in Baghdad, waiting to be tested, waiting to end the argument, waiting for someone to ask the right question. Does the copper show electrolyte damage or not? And the only way to settle the question is to test the original, which brings us back to where this story always ends. A locked museum, a lost war, and an artifact that might rewrite the history of electricity. The jar is still there, somewhere inside those walls, and it is still capable of producing voltage. After 2,000 years, maybe another example. Or it may not. That is what makes it worth testing. The Baghdad battery may fit this pattern, or it may be a scroll jar. The honest answer is, we do not know yet. And that is the most important thing to say. What we know for certain is this: the components produce voltage when assembled correctly. That is demonstrated. Some Parthian artifacts have gold layers that are difficult to explain by any known ancient technique. And the artifact itself sits in a museum in a country that has endured decades of conflict until modern science can examine the original under controlled conditions. The debate remains open. Modern imaging could settle this debate if applied to the originals. Micro-CT scanning would reveal chemical deposits without opening the artifact. Electrolyte residue leaves a distinctive mineral signature on copper. If the original cylinder shows electrolyte damage, the battery hypothesis gains ground. If it shows only atmospheric corrosion, the scroll jar interpretation wins. The technology exists. The methodology is proven. The original artifact is the missing piece. Until modern science can examine the original under controlled conditions, the debate continues. 2,000 years later, a simple clay jar still divides the scientific world. It might be the oldest battery ever made, or it might be a jar for storing scrolls. Either way, the fact that a 2,000-year-old jar can still produce electricity says something more than we assumed. And we still have more to test. If you want to see what happens when scientists test another ancient object that everyone assumed they understood, watch the next episode. Because not every ancient mystery needs DNA to rewrite history. Sometimes a jar full of vinegar is enough.